Welcome to Cognito Key. You know, in the world of electronics, most components are designed to play by the rules, letting current flow in just one direction. But what if there was a component whose most important job was to break that very rule? Well, today, we're diving into a tiny device that does exactly that.
Think about it. Most diodes are like one-way streets for electricity. But the Zener Diode? It's completely different. It's actually engineered to work backwards. And this unique little superpower is absolutely essential for almost every piece of modern technology we use.
So how does it pull this off? In this explainer, we'll first, meet the Zener Diode. Then we'll uncover its breakdown secret. We'll also look at the difference between the Zener and Avalanche effects, see how it's put to work in the real world, and finally, understand its crucial role as a voltage gatekeeper. Let's get right into it.
All right, so first things first, what exactly is a Zener diode?
It's named after the scientist Clarence Zener, and it's a special kind of diode designed to operate in what's called the reverse bias breakdown region. Now, in simple terms, that just means it's built to handle electricity flowing the wrong way, and that right there is the key to its power.
So what's so special about this breakdown region? Well, this is where we see the Zener diode's real magic. It's all about how it handles pressure when electricity tries to go backwards.
See, if you push too much reverse voltage through a regular diode, it just gives up. It breaks, and it's permanently damaged. A Zener diode, on the other hand, is built for this. It's engineered not just to survive, but to start conducting current safely at a very specific, predictable point, called the Zener voltage.
And what's really fascinating is that this breakdown isn't just one single event. It actually happens in two different ways, depending on the diode's voltage rating. We call these the Zener breakdown and the Avalanche breakdown.
The main difference between them? It's the voltage. Below about 5 volts, we get what's called a Zener breakdown, but go above 5 volts and it becomes an Avalanche breakdown. The result looks similar, but the physics behind them are totally different.
In a Zener breakdown, the electric field inside the diode becomes so incredibly intense that it acts like a brute force. It literally just rips electrons free from their atomic bombs, and that creates a sudden rush of current.
Avalanche breakdown is, it's more like a chain reaction. Imagine a free electron getting accelerated so fast that it smashes into an atom, knocking more electrons loose. Then those newly freed electrons do the exact same thing. It creates this cascading effect, like an avalanche of current. Okay, so we've got this component that can reliably hit a specific voltage and then just open the floodgates for current. That's a really powerful tool. But how do we actually use it?
This special ability makes the Zener diode incredibly versatile. You'll find it used for switching operations, for clipping and shaping electrical waves, as a super accurate voltage reference in all sorts of circuits, and even to protect sensitive measurement tools from getting fried by too much voltage.
But out of all these jobs, there is one that is by far its most critical and most common mission, and that is to act as a voltage regulator. Imagine you have a power source that's unstable. The voltage is jumping all over the place. A Zener diode in the circuit acts like a dam. It holds the output perfectly steady at its Zener voltage, let's say 5 volts, no matter what. Any extra voltage is safely diverted through a resistor, which means the delicate microchips downstream get a perfectly stable supply of power.
And this function, this one job, is precisely why this tiny component is so indispensable. It's all about creating stability in a pretty chaotic electrical world.
The core principle is really that simple. It maintains a constant output voltage, and it just doesn't care about variations in the input voltage or the current being drawn. It creates this perfect little bubble of stability for sensitive electronics.
So really, you can think of it as a tiny, unwavering gatekeeper for your electronics. It just stands guard, making sure that the sensitive microchips in our phones, our computers, get the exact stable power they need to work, protecting them from all the unpredictable spikes and dips of the electrical world.
So I'll leave you with this thought. In a world where power from our outlets can vary and our batteries are constantly draining, what would our precision electronics even do without this simple, reliable little voltage gatekeeper making sure everything runs smoothly? If you found this explainer helpful, please do give it a like, share it with others who might find it interesting, and of course, be sure to subscribe to Cognito Key for more deep dives into the tech that shapes our world. Thanks so much for watching.